Hey, I'm having such fun technically today. Don't know what's going on. Okay, so I see I'm recording, got my headset on. Okay, video two of polynomial functions. Okay, out of the three kind of sections in this chapter, I think this one's actually the easiest because literally you have to memorize. No, you have to memorize. It wouldn't hurt you. You need to know one chart. Okay, you do, and you have to put this on your formula sheet. I'm just going to look up at the board to see what I had to do. It's a degree. So it's the same one we have. Leading coefficient. And it's actually the sign. I don't care what the number actually is. And my visual aid. With an E. Okay. Wow, my writing's awful this morning. And we're going to do degree odd. And the leading coefficient is going to be plus, it's going to be minus, and then it's going to be even. We're going to be plus, and we're going to be minus. Okay. So this part is about end behavior, which literally is saying where does the graph, what quadrant does the graph start, and what quadrant does the graph end? Oh, I better finish my chart and then I'll get into the explanation. Okay. Um, Lots of clever people out there have all this memorized. I haven't bothered. I just know the pictures that go with each one. There, that's it. Um, so if it is an odd degree with a positive leading coefficient, it's an uphill. It's going to start down here in 3 and end in 1. If it's an odd degree with a negative coefficient, it's going to start up there in 2 and end in 4. I don't even know if you can pick up the little pauses I have to think. It's just, I know the picture. And then when I have to count, I can. So uphill, downhill. If it's an even degree and positive, then it's a smiley face, which is like just a positive parabola. And if it's an even and negative leading coefficient, it's a frowny face or an upside down parabola. So I guess we probably should make sure that everybody knows what a leading coefficient is. But everything goes back to this chart. All right. So make sure that's on your formula sheet. Okay. The leading coefficient and degree are in the same term. They're not the same thing, but they're pretty close. And I actually should have put degree first and then leading coefficient because degree is what you look for. So your equations are basically going to look like this. Or some mess, something. Because I'm always just making them up. All right. So first thing you do is you look for the highest exponent. Now, if it's a nice assignment or if I set the right check boxes on it, it will be the first term. But you just look for the highest exponent. So since I'm making these up, well, come on, say it out loud. Be brave. Pretend I can hear you. There you go. That is my, did I really just circle the biggest little number up top? Yeah, that's all it is. Your highest exponent anywhere. Okay, so it can be there. Mm, I don't know. My brain's not coming up with new ones pretty fast this morning, but that's all you're doing is you're looking for the highest exponent. So as I scan through here, oh, look, I only have one exponent. Okay, done. What about this one? Ooh, if you were in my grade 10 class last year, you should know, or you've been paying attention, you should know. There's always an understood one if there is no exponent written. All right. So this equation is degree 9. This equation is degree 2. This equation is degree 1. They'd say first degree, second degree, ninth degree, whatever. Seventh degree. Check. Are we done? Yes. If you're looking for degree, that's it. Done. Excuse me. The leading coefficient is the number that goes with that. Okay. So you got to be sure to include any sign that's out front. So this has a positive leading coefficient. Um, sorry, I'll put a plus in there, right? Understood plus. So this is also positive. This one is, okay, kind of boring, a negative. So what I need, and honestly, I should have done this. I don't even care that it's 9. All I care is whether that degree is odd or even. So this is odd positive. I'm going to put it in the order of the chart. And this is, the 2 is even, right? If you're having one of those moments, even just means you can divide it by 2 and you don't get a decimal. So if I take 9 and I divide it by 2, I get 4.5. So it's odd. If I take 2 and I divide it by 2, I get 1. So it's like a nice whole number. So it's an even one. This is odd. And this is also odd. Okay, so I kind of forgot to give you many evens. So now I go odd, positive, and I go back to my little chart, odd, positive. My visual aid says that. Now it just looks like I made a scribble. But that's enough for me. I know it goes uphill like that. Just a reminder. Yeah, this works. When you have your graph, 1, 2, 3, 4. Okay, so I'm starting down here. So basically my line's going to go like that. My start is in 3. My end is in 1. That's the entire question. That's it. That's all I'm asking you to do. All right, let's try it again. So this is even positive. So I go up here and I go even positive. So that's what I'm looking for. I'm just going to redraw it because it makes me happy. 1, 2, 3, 4. I started in two. Oops. And in one. So the rule is you always number your quadrants that way. I don't know who made the rule, but that's the rule. You always go this way. And when you're reading a graph, it's like reading a book. You start at the left and you go left to right. So your only options for your starting quadrants are either two or three. And your only options for your end quadrant or the end behavior is one or four. I don't care what happens in the middle. So odd positive. Oh, well, oops. Let me just move it down. Odd positive, that's that one. Start one, two, three, and one. You know what? As I'm doing this, it might be worth you writing these out. Because really, there's four options. Um, I'm a visual learner, so I tend to draw the little diagrams, but you got a formula sheet. Why wouldn't you just write this stuff? Okay. Last one is odd negative. So I know odd negative goes downhill like this. So I'm starting in two and in four. Okay, so here's the deal. That, yeah, it's a scribble. You figured that out. But I don't care what goes on in the middle. I am starting here. So that is one, two, three, four. So I'm starting in three. Whoops. I'm ending in one. So I don't care what goes on in the middle. Just look for your start and your end. If I remember right, this had to do with when we originally started teaching it, it had to do with limits in calculus. So this will kind of doing a prep for it because it just seems like, so what? Honestly, it's like, yeah, okay. And now what? Doesn't matter. All you gotta do is end and start and end. Um, wow, I started a video and the other one was really long. This one's not going to be very long. Let me get out some of my pictures because sometimes you're going to get asked leading coefficient and degree of an actual diagram as opposed to an equation. Because, you know, when you start with an equation, like we did here, not very difficult. We just did that. How about this one? Okay. So I designed these cards for a slightly different activity. So it's got both. It's got both the diagram and the equation of it. So we go through and there. Let's say that's all we have. So we go through and we find our our highest degree, biggest exponent. All right. So three is odd. And then I look at the coefficient, so the big number in front, and it's plus two. And I just want to make sure that it's clear. I don't care if this is 1, 3, 5, 7, 9, 861. As long as it's odd, this rule will follow through. And this plus 2, I don't care what that number is. All I care is it's positive. 2, 4, 8.6 doesn't matter as long as it's positive. So odd positive. And this, again, this is just because this is how I remember it. It's uphill. I'm twitching. Um, I know most of the time I tend to draw it to the center. It doesn't matter. All I need to remember is it's an uphill line. 1, 2, 3, 4. So start 3 and 1. Now let's see. And indeed it did. It started to end. Oh, the other thing with these diagrams with pictures, if you're talking about quadrants, it's probably not a bad idea to highlight the axes. So just find the 0 in the wherever it is in the picture. Because sometimes I'll make it nice and it's all centered and pretty, but sometimes my graph isn't that pretty. Sometimes it's like mostly above the line and there's no use giving you a whole bunch of stuff. I need to stop talking about that. That would be a teaching thing. Okay. But ta-da, 1, 2, 3, 4. I was right. That's all there is to it. Hmm. How about that one? All right. Turn off the TV. Pause the video and try it yourself. All right. Let's do it the way we just did. Let's see what we can get out of the equation and go from there. Okay, highest exponent, which is the degree. Well, usually there's only one. And 2 is an even number. And the leading coefficient, I don't really care. It's 0.4. Or sorry, negative 0.4. All I care is it's negative. Okay, so I know that gives me an upside down parabola or a frowny face. So I'm going to start end in 4. Yeah, that seems about right. One thing I was going to say again, if you're doing a bunch of these, always go at the very end and go, make sure your start is either 2 or 3, 2 and 3. Okay, sorry, 3 and 3. And make sure your ends are always 1 or 4. 1, 4. Yay. All right, let's look at our picture. Well, it's pretty much exactly what I drew. So you can see again this time, if I highlight the quadrants, it makes it a lot easier. Or highlight the axes. And we are indeed starting in 3 and ending in 4. Sorry, I'm just looking for one of the interesting pictures. Oops. Oh, well, this will do. Okay. See that sucker? Nope. I don't know if it shows it up on your screen, but this stuff only works if it's a function. All right, this thing is a relation, so just garbage. Has to be a function before all of these rules work. Um, so yeah, memorize that chart. This is, I don't know what else I can show you. That's a parabola. Let's do one more. Sure. Okay. So again, the starting, if you have the graph, you honestly don't need that part. Just figure it out. Okay. But if you have only equation, then you have to think a little harder, although honestly, not particularly. Highest exponent, not being very creative. Do that's 4. So that's even, and it is positive. All right, so now the sign in front of the term that matters. Smiley face. So starts in so start is equal to 2 and is equal to 1. And even if I drew that parabola like deeper down like that, it's still going to be the same. I guess I could ask the question going the other way. This is going to be the last question. Um, oh, there was a graph, but I used it for the other assignment. Oops. Whee! I don't know. It's an equation of some sort. We're just going to pretend. We're also, wow, that's really bad. Um, we're just going to assume that no parts of this graph are vertical because then it's a relation and everything falls apart. So there's my start. There's my end. So start is equal to 1. You don't have to do this, but it's just easier when I'm teaching. And I really hate being wrong. So my start is down here in 3, and my end is in 1. So this is what I do as I just go, I don't care about the wobbles in the middle. All I care is about from there to there. So that is going to be an odd and positive. How do I know? Because essentially it's that graph with just some in the middle. Anyway, I have run out of energy and I think you got it by now. Practice, practice, practice. If you need, ooh, hold on. I want to see if I can do this. Go to Desmos, is what I'm saying. So stop my share. Rid of this. I'll be back. I don't know. Chat quietly to your cat. Sing a song. Whatever works for you. Okay. I know I'm still recording. I could start singing, but I think we're good. There. Unshare. You are screen sharing. Oh, there it comes. Okay. All right. So when it gets weird and you're not writing a test, you're doing an assignment, or you want to practice, you want to learn, get onto Desmos. Um, I don't know, type in Desmos. I've got a shortcut on my desktop. Y equals. All right, I'm going to do that one I just made up. Okay, I need to move some stuff. Minus x. I don't need that anymore. Sorry, talking to myself. All right, so just so you know, there's this little keypad doodad in the corner. If you need to do exponents, I had x to the 3. Look at that. That's pretty cool. Um, plus 2x. As you add bit, it does strange stuff. And now we need another exponent, and it was to the 4. And look at what happened. It suddenly went from, oh, now it just says I messed up. All right. Oh, yeah. So we'll need to scroll out, and we can find it down there. So even if I scroll up, scroll in really close, you can see there's a little bit of an extra wibbly whoop going on down here. What we really care about is not that. We care about where we start. So we are starting in 2 and we are ending in 1. I'm staring down at my thing down there. Now, that awful thing that looked like a, I don't know, Loch Ness monster that I drew, I don't think I can do that. Oops. What I can get it to do, whoops, I might stop pretty soon because I don't need that. So you got a nice little parabola there, but you know what? That's enough. So there's an X and an X and an X, 3 X's. X times X times X is X to the 3rd. So this one is coming out as an odd positive. See, starts down there and goes up there. Now, if I add another X, oh, I want a 9. And I just want an X. No. My wooble back. It doesn't like me. Sure. I don't know what it's doing. I'm just gonna say we're good because this part just got weird. Anywho, um, that got weird too. Have a lovely day. Um, yeah, sorry about the Desmos, but play with it. If you have an actual written out equation, instead of using the brackety bits that I was trying to use, it'll work much better. Well, hey.